Hi there and welcome back. We begin Chapter 8, and Chapter 8 is about radicals, square root, cube root, fourth root, and so on. And I'm going to assume that this is work that you are familiar with. For example, square root of 4 is 2, square root of 9 is 3. And so we begin to say, okay, what are the numbers that you can take the square root of? And those are the numbers that are called the perfect squares. And the perfect squares are 1, 4, 9. In other words, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and so on. So those are the numbers that are squares, and so those are the numbers that you can take the square root of and get a nice integer. Right now, it's important to note that something like minus the square root of minus 16 is undefined. We'll learn how we can work with that, but for right now, square root of minus 16 is undefined because there's no number such that that number times itself is going to be negative. If you multiply two positives, you get a positive. If you multiply two negatives, you get a negative. So we'll wait on this and we'll learn what that is shortly. Okay, so let's talk about how we simplify a radical expression. Now, if we have something really easy like the square root of 16, that's 4. But how about if we have something like the square root of 8? I should mention that there is a property of radicals that if you have the square root of a times b, that is the same as the square root of a times the square root of b. So the trick on simplifying radicals is to write it as the product of a perfect square and something else. So what perfect square is a factor of 8? I hope you said 4. So we can write 8 as 4 times 2, and then we can write it as the square root of 4 times the square root of 2, and that simplifies to just 2 times the square root of 2. Here's another example, a little bit more complicated. 3 times the square root of 72. And so you need to ask yourself the question, what perfect square is a factor of 72? So just go through that list of perfect squares, and the biggest one that you can pick is 36. And so this is 2 times 6 times the square root of 2, which is 12 times the square root of 2. Okay? Sorry, that was a 3, so this is 18 times the square root of 2. Okay, now let's look at some things. Square root of x squared means what is it that you multiply by itself to get x squared? Okay, and that's going to be x. Square root of x to the fourth. What is it that I multiply by itself to get x to the fourth? X squared times x squared is equal to x to the fourth. I guess I should do that. And so this is simply going to be x squared. See the pattern? Square root of x to the sixth. That's going to be x cubed. Square root of x to the 25th. How about that? Well, what I do with that is I write it as the square root of x to the 24th times x, and the square root of x to the 24th is x to the 12th. And that's because x to the 12th times x to the 12th, you add the exponents and you get x to the 24th. So that's how the square root of x to the 25th simplifies. Okay, let's look at an even more complicated example. Okay, so check this out. So I'm going to write this as the product of two terms, one of which I can take the square root of. So now think about this for a second. What are the powers of x that I can take the square root of? I can take the square root of x squared, x to the fourth, x to the sixth. So they're all even powers of x. So first of all, I'm going to write this as 4, and then I can write it as x squared, y to the fourth, t to the 12th, all even powers. Well, what's left? A 5, and an x, and a y. So this is equal to 2x y squared t to the sixth times the square root of 5xy. So try to think about that. I guess, if I wanted to write it as a rule, what I'm saying is if you have the square root of x to any even number, which can be written like that, it's simply going to equal x to the n, and that's because x to the n times x to the n equals x to the 2n. Okay, got that? Alright, see you next time.